A little trickier parabola graphing problem. It starts off with a lead coefficient of 2. Definitely don't try to get this into perfect square format. We're just going to find the axis of symmetry and then plug in what we get. So again, the axis of symmetry formula is x equals negative b over 2a. This case a is 2 and b is 7, so we'll have negative 7 over 2 times 2, and we get this ugly fraction, negative 7/4. You can change it into a decimal, but it really doesn't matter. We're going to plug this back into the function to find what y is equal to, so we're going to evaluate g of negative 7/4. So this would be 2 times negative 7/4 all squared plus 7 times negative 7/4 minus 4. If you type this all into your calculator, you're going to get negative 81/8. Make sure you use all those parentheses, and if you don't get negative 81/8, you'll get negative 10.125. Alright, so this gives us our vertex of negative 7/4, negative 81/8. This is great except for one thing. It's really hard to graph this coordinate. So what we're going to do is we're going to convert it into decimals now. So we're going to get negative 1.75 here, and 81/8 is that negative 10.125. And obviously we're not going to be able to get that precise, but it kind of gives us a good location on the graph. Alright, and then we still have to find the Y-intercept and the X-intercept. So the Y-intercepts, x equal to 0, and we're going to shortcut this one. The first two terms are just going to go away, and you're going to be left with negative 4. So g evaluated at 0 is going to equal negative 4. That gives us the coordinate 0, negative 4. And that'll be the Y-intercept that we have. X-intercepts, and we're going to let the entire function equal 0 and see what happens. So we're going to get 0 is equal to 2x squared plus 7x minus 4. Again, you can choose to use the quadratic formula. There's nothing wrong with it. It's just sometimes if it does factor, factoring is a lot quicker. In this case, we're going to multiply 2 times 4. That'll give us 8, and we're looking for factors of 8 that subtract up to 7. Well, that would be 8 and 1. So I'll use a positive 8 and a negative 1. And we still have that negative 4, oops. And we still have that 2x squared. And if you don't remember this type of factoring, quadratic formula comes in kind of handy. GCF of the first two is 2x. Left behind will be x plus 4. GCF of the second two will be negative 1. And left behind will be x plus 4. So we can yank out the x plus 4 and leave behind the 2x minus 1. And don't forget, this whole thing is still equal to 0. Alright, so out of this we're going to get negative 4 and positive 1/2. So that gives us two coordinates, negative 4 comma 0, and the other one would be positive 1/2 comma 0. Alright, so here we have our vertex in decimal form, which seems a little bit nicer. We have our Y-intercept and we have our X-intercepts, and then we just have to graph. Alright, most of these plots are going to be really approximate, but we want to get them in at least the right neighborhood. So the first one here is negative 1.75, negative 10-ish. Negative 1.75 is almost negative 2, so we're going to get really close to it. And then I got to drop down 10 from there. So I'll be right about here. If you make your point big enough, it'll cover enough space. 0, negative 4 would be right here. Or it's on the y-axis. I almost put it on the x-axis. Which wouldn't be bad because this one is that. Negative 4, 0 is here. 1/2, 0 is halfway between 0 and 1. And then we have that axis of symmetry crawling down really close to this -2, but a little bit to the right. That'll go right through our vertex. So these become our 4 main points, and then we're going to do our reflected point. Now this one gets a little tricky. It's 7/2 to get to the axis symmetry, and it's another 7/2, so that would be, 7/4. So 7/4 to get there, another 7/4, that would be 14/4, better known as 7/2, which is right about here. 7/2 being 3.5. So we'll get a point over here, and we can finish off our parabola. So here is the 4 main points with the axis symmetry perfectly placed. And then we have our 5th point over here at 3.5 down -4, and we'll just draw our parabola through those points.